Hi everybody, welcome to week 7 of your college algebra class. This week we're going to cover chapter 8. Chapter 8 is all about systems of equations, and what that means is solving when you have two equations and two variables. So this is some of the examples when you look at the application problems are going to be those what we think of as those typical, like if a train were traveling in one direction and another train were coming in another direction, how long until they hit, kind of a thing. Those kinds of word problems are examples of two equations and two variables. In other words, a system. What we're going to look at in the first 3 sections of this chapter are ways to solve these systems of equations. And there's 3 basic ways, and there's basically pros and cons to each. So the first one is, let's talk quickly about what do we mean by a solution. What we mean by a solution of a system is we want the answers that will solve both equations. So they're going to make both equations true at the same time. So basically what that means in this first method is, do they intersect? So if we have these two equations, these two lines, and we graph them, and here's just an example. Here's 2 equations, 2 different lines, and you notice that they intersect at that point, -1, -2. What that means is that point, if you plug it back into either one of those equations, it will solve both of them. So a solution of a system is a point that will work in both equations. So this method, solving by graphing, is probably the most visual method. You can just plug the equations in, pop them onto a graph, and wherever they cross, that's the solution. The downside to this, however, is it might be hard to find, okay? What if they are equations like this, where they don't intersect? Then, you're going to be going, well, I'm not really sure. Did I graph them wrong? What's going on there? So that's kind of a downside to this particular method. We talk about inconsistent and consistent systems, and that's what those 2 pictures just illustrated. A consistent system means they have one solution. Inconsistent means they have no solution. So when the lines are parallel, like they are here, that's an inconsistent system. They're never going to cross. When they do cross, like they did on this one, that's a consistent system. So those are just some terminology that they're going to introduce to you in section 1. Then we're going to go on and we're going to look at another way to solve, because as we said, solving by graphing is not necessarily the easiest way to do it. So let's take a look at section 2. Section 2, we're going to learn how to solve by substitution. So the substitution method basically means we are going to solve one of the equations for one variable, and then we're going to take that and plug it into the other equation. And they go through several examples. Here's the first example. We've got 2 equations, x equals 3 minus y, and 5x equals 3y, or 5x plus 3y equals 5. Those are your 2 equations. So the first one's already solved for x. So we're going to take that 3 minus y, and everywhere we see an x in the second equation, we're going to put 3 minus y. And so they show you how we do that and how we go through and solve using some of those methods that we learned earlier in the course. And then once we know what the solution is for 5, we'll go back in and put it into the first equation and solve for x. So that's solving by substitution. And they actually show you in this chapter how you can check it by graphing. So here, going back and using the first method to check the second method. The third method that they're going to introduce you to is solving by elimination. And what that means is we're going to write 2 equations, and we're going to put them one over the other. And here's an example. And we're going to add those 2 equations together. And so if you notice, the signs of the y are opposite, and the coefficients are also the same. So when we combine those, we can eliminate the 3y's, the 3y on top and the minus 3y on the bottom. So that's why this one's called elimination. So if we combine the two equations, we can get rid of one of the terms. So this is just the work that shows you how that happens. As you can see, when you take 3y minus 3y, we end up with no y's. So the y's go away. When we continue, though, we add the x's. 4x plus x is 5x, and then 8 plus 7 is 15. So then we're left with just one variable. Solve for x, and then plug that back in and solve for y. And again, we can check it by graphing. So here's an example of the graph. Now, ultimately, the idea here is that there's going to be one method that's easier than others. You can use any of these methods to solve any system. It's more preference and what's the easiest to do with that particular set of equations. And so in section 3, they do also give you kind of a pros and cons table. So what are the strengths, what are some weaknesses for each of these different methods? So, you know, this might be a great place to kind of review. As you finish this chapter, you'll see applications of these methods. You're also going to be introduced to, well, what happens if there's 3 variables instead of 2? How do we solve that type of system? So that's covered in this chapter as well. If at any point over the next few days you have any questions as you're working on this, please make sure you reach out to me. You can email me, call, or text. My number is 618-792-2293. Have a great week.